Up with number 11. If you, okay, no, thank you. If you notice these little tick marks here, we just had 2 of them in the tick marks when we were dealing with these. We use those to indicate 2 sides are congruent to each other. So when you were told that these 2 sides are congruent to each other, that meant that we had what we called an isosceles triangle. Isosceles triangles have 2 congruent sides. And then what this question is then getting at is not only are the 2 sides congruent, but so are their opposite angles. So the opposite angle of this one is that angle. And the opposite angle for this side would be this angle. And we wanted one of those opposite angles. What you're given, other than the markings, is the idea that the other angle, the 2 that we're not concerned about being congruent, are 100 degrees. So it brings together some old ideas that we talked about yesterday, along with now the isosceles and the 2 congruent angles. There are 180 degrees overall. If I subtract away the 100-degree angle that we know is up here, that leaves 80 degrees to make up the 2 congruent angles. So if these 2 congruent angles have to add up to be 80 degrees and they're congruent, that would then tell us that each one of these has to be how many degrees? 40. So we just cut that right in half since they're congruent, 80 total. That means that X has to be a 40-degree angle, okay? So that's those, just understanding isosceles triangles. These opposite angles are congruent, okay? All right, next one. We talked about something called an angle bisector. That little phrase basically describes what's happening. So when you see an angle bisector, that means we are bisecting or cutting in half. The idea of bisecting means we cut in half an angle. So when we look at this diagram, this guy right here is what is the angle bisector. So each figure shows a triangle with one of its angle bisectors. You were then told that the measure of angle 2 is the expression 4x plus 6. And then the measure of angle 1 is this 3x plus 13. Well, the whole idea of a bisect means we cut it in half. So whatever this big angle would have been at the beginning, once we cut that in half, doesn't angle 1 and 2 have to be equal to each other? Okay, so that's where we now, algebra-wise, how we set up our equation. We know that that angle 2, which is 4x plus 6, ends up being equal to angle 1, which is the 3x plus the 13. From there, we solve. So we're going to subtract that 3x over so that we get 1x plus the 6 equals a 13. Subtract your 6 over, and we should get x to be 7. Make sure, again, on that final, tomorrow and Monday, that we are answering the question. In this case, it is x, but I could just as easily ask you for angle 1, and then you need to be taking x and plugging it in and figuring out what angle 1 is. So just, again, make sure you're answering the question, and that's our answer. All right, 14, again, same idea. So we're going to do one of each. So make sure we can recall all of these. All right. 15. Go ahead and do 15. We should be able to do that one, I would hope. All right, and this is telling us it's a 90-degree angle overall, right? The little square there is what that means. We had 44 degrees accounted for. So if we started with 90, but one of the angles is 44, then the angle that remains would have to be whatever's left, which would be 46. Okay. And then same with 16. Okay, these guys. Remember, we had alternate interior, alternate exterior, corresponding, same side interior, all that good stuff. those are all based on the idea that we had a set of parallel lines. So here are parallel lines. And then we had what we call the transversal, which is just a different line that cuts through those. And then we create all these different sets of angles. So we have a set of 4 angles up here, a set of 4 angles up here. So if we look at these, do this angle and this angle, we would first want to know, what are they? Are they alternate interior, alternate exterior? Are they all, corresponding, same side interior, all that good stuff? Anybody remember what those are?
Corresponding.
Good. So those are I like how we just, and it just is up there. So just being spoken to from the heavens right now, Cam. Yeah, these are what we call corresponding angles. And I still don't know why sometimes it's up there and sometimes it's in my computer. So corresponding angles, and then what we want to know is, when we did all of these sets of angles, some were supplementary, some were congruent. Corresponding angles are congruent. So if this was a 94 angle, that tells us that this is a 94 degree angle. Okay. Corresponding angles apply to 17 and 18. So we're going to kind of jump along a little bit here. Those are both corresponding. So number 18, B has to be 99. All right, if we go to 19 now, we have a different type of an angle. Here are the parallel lines. So this line here is parallel to this line here. Remember, the little arrows on the line tell us that. Our transversal is this. All right, those are what kind of angles? The B and the 76. Good. Those are alternate interior angles. Good. Thank you. So they're inside of the black lines. So we talk about they're inside of the parallel lines, but they're on opposite sides of the transversal. Those are alternate interior. And then alternate interior angles are also congruent. So if this angle is 76, its alternate interior angle must also be 76. That is 19 and 20 are alternate interior angles. Okay. All right, these guys, parallelograms. So these had a bunch of properties as well. And again, that's why do these reviews, because we're not going to show you 1 or 2 properties in this and then test you on the other properties. So that's why if we know how to do this, you should be pretty good. If these are parallelograms, what we talked about is opposite angles. And you can kind of just be intuitive about this, what would make the most sense, because pretty much are always either congruent or supplementary. Those are the 2 most common words we talk about when we're dealing with all these geometry topics. If we just look at those 2 angles, would they just appear to be supplementary, or would they appear to be the same degree measure and be congruent? And what do we think? We did just do this kind of anyway. Opposite angles are going to be what? Congruent or supplementary? Best guesses. We just look at it. Ahmed, what do you think? Yeah, they're congruent. If we look at these angles, these are both bigger than 90 degrees. So those would appear to be congruent. Consecutive angles are supplementary. So opposite angles, that's what we're dealing with here in a parallelogram. So opposite angles are going to be congruent. What that allows us to do, since we're defining these with variables, at least one of them, we have to set up an equation. We know they should equal each other. They have the same exact degree measure. So that 10 plus 10x has to equal the 120. And then we just go through, solve this. And we should get x to be 11. Yes, Kim?
Are you recording this?
I am. Yes, I believe so. Yeah, I am.
Okay. So I can go back later and watch this. Right?
You could. Yep.
Okay. Cool.
Yep. All right. Now, when we go to number 22, let's look at this first angle that I gave you. Its opposite angle is this guy over here, and we want nothing to do with that. The question is in dealing with this. So these are now, when we compare these 2 angles, these are consecutive angles. If I know 65x, the very next angle is 115. So these are now consecutive angles. So these are not opposite. And then what we would want to know, and again, it's pretty much, if in doubt, tomorrow and Monday when you're taking this, or next week if you're taking it still, consecutive. There you go. It's either congruent or supplementary. So if we look at these, is there any chance that this angle here, which is greater than 90, is going to be congruent to this angle here, which is less than 90? No. So that means that they're probably supplementary. And that is the case. Consecutive angles in a parallelogram are supplementary. Ooh, that's really bad writing. I don't like writing on Cami. It makes my writing look worse than it already is. All right, they're supplementary. So now our equation, if they're supplementary, means they have to add up to be 180. So that's what we set up. We take the 65x, we take the 115, they need to be added together. And when we add them together, we know they have to equal 180 degrees. Okay, and then we just hammer that out. Subtract 115 from both sides. That very nicely is 65 also. So that when we divide everything by 65, we get x2 equal a 1. So parallelogram, opposite sides are congruent, consecutive sides are supplementary. Other properties of parallelograms is opposite sides, which we have here. They're not just parallel, that's certainly one of the things. That's the whole reason they are called parallelograms, diagrams with parallel lines. So that's one thing, but opposite sides are also congruent. So if we know that, then the x minus 4 has to equal 7. That's our equation. Add the 4 over, you're going to get an 11. Okay, pretty easy. 24, also pretty simple. We're going to skip that guy. All right, these guys, find the measurement indicated in each parallelogram. So DW is 19. So DW, I'm telling you, is 19. And then I am asking you for the whole thing from D to F. So the property that this is testing you on is in a parallelogram. These are what we call diagonals, what you see in here, E to C and then D to F. And diagonals in a parallelogram bisect each other. So what that means is this guy right here, this big fat dot that I'm putting in my diagram, since each of those is getting bisected by the other, this is the midpoint for both of those two sides. So what that then means, if this is 19, wouldn't that then mean that this guy is also 19 since it's in the middle? The question is asking you the entire length from D to F. So if they're both 19, then we know that is 38. Okay, so diagonals bisect each other when we are dealing with a parallelogram. Yeah, and then 26, pretty much the same thing. All right, next ones. See if we remember these. So if I gave you number 27 and you get a question like this, what is the most specific name? And what I mean by that, maybe we'll talk about the first one a little bit, although it doesn't show it. I want to say we should have had some parallel lines drawn here just to make sure there's no confusion on this. So this is for sure a parallelogram, but that's not necessarily the most specific name. All right, because there's a flow chart. The parallelogram is the most general one. It just needs to have opposite sides that are congruent, which this has, and opposite sides need to be parallel. But then we went down a flow chart where we had rectangles, rhombuses, and then eventually at the bottom of it, we had a square. Write down which one of those you think. So here are your options: rectangle, rhombus, and a square if it's a parallelogram. Okay, anybody brave? It could be parallelogram, by the way. I mean, sometimes that is the answer. It's not in this case, so don't say that. I think I spelled rectangle wrong also while I look at it. Here we go.
Isn't it square?
Why do you think it's a square?
Because it has like the most rules, right?
That is true. The squares have the most rules, most things that have to happen. Here's what has to happen in a square. So first it needs to be a parallelogram. You need to have 90-degree angles everywhere. Do we have 90-degree angles everywhere? Yeah, and then the other big thing is all sides are congruent, and then I'm going to highlight the word all. What did Bisher say? Okay, because are all sides congruent here? Notice the markings. If I have a single tick and a single tick here, it's telling us these sides are congruent, but notice how the other two sides are marked differently with 2 ticks? That means those are not, the single ticks are not going to be congruent to this. So we wouldn't say they're all congruent, but since they do all have 90-degree angles, it's just a rectangle. Okay, Cam? All right, so now look at number 28, Cam. Notice how we have right angles everywhere, right? Just like number 27 did. Good. All the sides now have the same markings, telling you that all the sides are in fact congruent. That's your square. Okay. All right. 29. Actually, write down 29 because it's not on our flow chart. See if we understand what we would name this. Oh yeah. There you go. As a hint, the word is not currently on the screen. Extend our flow chart upwards. Because this doesn't have any of the specific things. There's no parallel lines, which we need for a parallelogram. Certainly not a rectangle, not a rhombus, not a square. But what these all are that we have here, so every one of these 27, 28, 29, 30, 31, and 32, those are all, remember the prefix quad, which means 4? Yeah, it's just a general quadric. We're trying to be as, you're right, we want the most narrow thing as we can possibly come up with. And in this case, that's all we can come up with because you're not told any sides are congruent. You're not told any angles are congruent. Nothing's parallel to each other. So this guy is just a good old-fashioned quadrilateral. All right. Okay, 30. I extend over here. Remember we had something called a kite where consecutive sides are congruent. So notice how these are consecutive sides congruent. These consecutive sides are congruent. So that's what we call a kite. Consecutive sides being congruent. (31). Notice how opposite sides are said to be parallel. But do we have, if we go to our little flow chart, so it's definitely at least a parallelogram. Do we have right angles anywhere? No. And do we, rhombuses mean all sides are congruent? Are all the sides congruent? No. So as specific as we can get with this one is the word parallelogram. It doesn't satisfy any of those more strict terms. And then 32, we didn't do a bunch of these. There's actually one more. Remembered something called the trapezoid? Dealt with it a little bit, not too much. A trapezoid has only one set of parallel sides. So notice how parallel here or parallel here. That is a trapezoid. It's actually an isosceles trapezoid, but we won't go there. We'll just say that it's a good old-fashioned trapezoid. Okay, so have these in front of you when you get to the question that's going to test you on this. If you have these handy, look at it real quick, use that as a guide, and hopefully then we don't have a problem. I'm going to leave you 33, 34. Let's move along. In a even if you don't know this is a trapezoid, well, yeah, let's do it. So we're told it's a trapezoid. I hit the wrong thing. And we want to find the measurement of each of these. All right, so you were told that this is 115. Now, think here. So be smart in terms of what we're trying to figure out. If I'm looking for this angle, notice how these are across from each other. Do those look like there's any chance of them being parallel to each other? Or, I'm sorry, congruent to each other? Meaning, if I ask you this angle, plus you're given it, isn't that greater than 90 degrees? If I go to this angle, what do we think that is, greater than or less than 90 degrees? It's less than, right? So there's no way these are congruent to each other, opposite angles, okay? All right, so the only other real option then is these two angles would be what? Yeah, supplementary. So I would just probably do the 180 minus 115, all right? That's what that opposite angle is going to have to be. It's got to be a 65-degree angle, okay? When you go to 36, though, notice how these aren't opposite of each other anymore. These are consecutive. You have this angle, and then we go right to that very next angle. Now, if we look at these, and again, there's pretty much only two things these ever are, congruent or supplementary. Do those appear to now be congruent? Yeah, those are both very much less than 90 degrees. These are congruent angles, so angle W would have to be a 46-degree angle. All right. All right, this I'm probably going to set up. I'm going to leave you this. You've been doing this since junior high school. We've done it plenty here recently. Just finding the missing side of a triangle, as long as it is a right triangle and we know two of the three sides. It's just a good old-fashioned Pythagorean theorem. Since x is opposite of your right angle, you just need to make sure that's your c. C is always the hypotenuse. And then you just solve that. You have all the answers, so you can do it. You can check it at some point in time. But that's Pythagorean theorem. 38 is the same thing, but just now understand when we go ahead and set up a squared plus b squared equals c squared, the hypotenuse, the side that's opposite of the right angle, that is your 9.8. So now you have to make sure that that gets assigned the value of c. And then I'm going to make 7.5 my x, or my a, and then I'm going to make the x the b squared. And then you just go through and solve that. But again, we're going to save a little bit of time. I'm going to hope we can do those on our own. All right, these guys. We dealt with similar polygons. So you are told that these are similar to each other. All right. Because they are similar to each other, all the sides have the same ratio. So when I ask you for the side length, in this case it's right here, what we need to know is what's the relationship from the one to the other. So if we look, notice how this left-hand side, and you're told they're similar, so we're not assuming this, and this left-hand side, those are corresponding sides. So what we did with these is we set up a little ratio with those. I took the 6 and I compared it to the 30. What that tells us is the quadrilateral on the left will always be 1/5 the size of the quadrilateral on the right. So if we then look at the corresponding sides that we're concerned about, we want this side, red, so we got to compare it to its corresponding side. So if this is 25, this side should be 1/5 of 25. So 1/5, good, of 25 is just 5. That's got to be 5. All right. Okay, good with that. Ella? All right. 40, same thing. The idea being similar. Same here. I want to get to some of the SOHCAHTOA stuff here. These are all similar triangle. Maybe these we want to talk about. This is something we haven't done yet. It says state if the triangles are similar. State if the triangles in each pair are similar. So state the similarity statement. Okay. So if you remember, we had angle, angle. That's one way we can prove it. we had side, side, side similarity. That was the second way. And then there was a third way of side, angle, side similarity. So that's what this is saying when it says how we know. It's going to be one of those three statements. And then our similarity statement, we've got it started over here. And then we would say it's similar to what triangle, and we need to line up their corresponding parts. So if we look at this, notice how there are two sides that are given. So probably not angle, angle, because there are no angles given to us. We are working with sides. And if we now compare like 12, should be similar to 36. So if I said 12 compared to 36, that's 1/3. If I took the other pair of corresponding sides, which would be another 12 compared to another 36, so that would be really hard to screw up because you're writing the same exact fraction. So far, so good. Two of the sides are good. What we would now need is a third side. So are we given any markings on these third sides? No. Or we would need an angle. Are we given any markings in our angles? No, but we talked about it yesterday, and it's something that's been reviewed over and over as we learn new stuff. Don't we have right here and here, don't we have vertical angles? And vertical angles are always what? Congruent. So this angle is congruent to this angle. And notice how those angles that I have the arcs in between, aren't those in between those two sides? So haven't we sandwiched the angle in between the two congruent sides? So we would say that these are in fact similar because of the side angle side similarity statement or theorem. When we go to now write our statement, notice how this, what we do? Okay, so we use the big triangle. I went from L, I went down the red side to the K, I went to the unmarked side to the J. So I have to do the exact same thing in the smaller one. So I'm going to go L, down the red side to W, and then down the unmarked side to V. That's our similarity statement. All right. Okay, again, I'm going to move along a little bit here. Through 45, you should be good. 46, yeah. Yeah, 47, we might want to do one. I wanted to do some SOHCAHTOA stuff, but we have done that most recently, so hopefully we'll be good. Go to 47. It tells you to solve for x, and then it tells you that the triangles in each pair are similar. So what that's telling us is we have this little triangle here, and it's similar to the overall big triangle. And they're similar to each other. So again, what that means is all their sides are in the same exact ratio. So what I'm going to do is I'm going to take the small side of the yellow triangle of 18, and I'm going to compare it to the big side of the big triangle, or the left side of the big triangle, which is 27. Okay, so this is the left-hand side of the small one over the left-hand side of the big one. If we go to the right-hand side, notice how I have the right-hand side of the small one as 10. So I now have to do the right-hand side of the big one, which is written as this variable expression x plus 2. From there, crisscross, multiply. That's how we solved these proportions back in the day. Oops, that's not what I want. Distribute, and then again, just do the algebra. We're pretty good at the equations, most of us, when we were going through all of these. A lot of equation solving this year. Subtract that 36 over. What is that, 234? Is that going well? 116? It's 234 divided by 18. Anybody there yet? No, it's not 16. 13? Yeah, 13. All right, so the next would be a 13. What do we got left here? Okay, we're inside of 2 minutes at this point. Just a reminder. So go through these. You're going to get some SOHCAHTOA stuff, some more recent stuff. Here are your answers. So I certainly the ones that we didn't get to, you would want to probably look at, make sure that you know how to do those. You'll know if you know what you're doing, if you can look to the back page and see that all these answers are correct. If there's any that you're confused on, you have 2 more sets of problems you can look at, see if you could reproduce those again. You have the answers as well. So tomorrow we'll do the first day. I'll give you half of the final. Monday, I'll give you the second half. Some of you will be done on Monday if you're happy with your score. Tuesday, you'll kind of make that decision. And then what is first period? Is that the second day, I think? 7th and 8th are the last, and then 7th and 8th are the last days, I think. So, and if you need to take it, you would then show up Thursday as planned for the final exam day, and you'll take it on Thursday. Did somebody raise their hand? I heard a beep. Yeah, Cam?
So we find out our grade right away.
Tuesday we'll let you know.
Oh, okay.
Tuesday we'll let you know what you got on the first attempt, and if you're happy with it, you're done. If you're not happy with it, then you've got to take it again on Thursday, and you'll do that all in one attempt because we have 70 minutes on Thursday for the final.
Oh, okay.
Okay. Also, if you have any questions tomorrow morning, I'll hop on. I'll set my reminder now. I'll hop on at 9. If nobody's there, I'll also just keep it on. If you have any last questions, you can pop in since you can't see us. But I'll hop onto our group, our page at 9 o'clock. Okay. Do you have a question?
So tomorrow we're just getting quizzed on the first part of the packet?
All 3 parts are the same exact thing.
Okay.
It's just more problems to kind of see. So it is on everything in that packet. Yeah, there's nothing new when you go to the next problem set. There's nothing new in those. It's just a reproduction of some of the ones we just did.
Okay.
Okay. Yeah, at home? Yes.
Can you repeat 39, please?
Yeah. Yeah, then you guys are good. It's 10:05. If you're at home and you're good, you can go. Say that again, Saleh. Which number?
39.
39. 39. Repeat, like you want me to do it again, or just want to see it? You there? Yeah, so when you were told that we have similar shapes, that means all the corresponding sides. So the top side here and the top side here, the bottom side here and the bottom side here, they all have the same relationship to each other. So let's say this was 2 and this was 10. See how this is 5 times bigger? So that means if this was 3, then this would have to be 5 times bigger. That's got to be a 15. Agree with that? So what we did is we took 6 and 30 and we compared them. So in order to get from 6 to 30, isn't that 5 times the size? Do you agree?
Isn't it 0.2?
So it depends on which way you're going to go. So here's, when we did that, this is 1/5, so that is 0.2. That's accurate. So what that means is this guy here is always 0.2 the size of this guy here. So now look at these red sides. See how the red sides correspond to each other? We knew the bigger side. We wanted the smaller side. So all I did is I took this big side that we knew, and we know the side that we want has to be 0.2 size of that. So if you did 0.2 times 25 on the calculator, that then would give us this smaller side of 5.
Oh, okay.
Okay? Yep, no problem. I'll see you tomorrow. Yep.